So now we will see about change of state of matter. So there are 4 stages that you can see when there is a change in the state of matter. So first one, melting. What is melting? So the process by which a solid changes into liquid. So you can see ice. So ice is changed into water. So the solid is changed into liquid, right? So when you take ice cubes and keep in the warm place, so the ice cubes melt, the ice cubes changed into water. So this process is called melting, right? M-E-L-T-I-N-G. So here what happens? So the molecules in the solid vibrates faster, and thereby the molecules will have a little amount of space. So they are converted into liquid. Next one, evaporation. So what is evaporation? So you can see here. So the liquids changed into water vapor, right? So this occurs, the process by which a liquid changes into gas on heating. So because of the sun heat, the water is changed into water vapor. So here also the molecules vibrates very faster, and thereby they will have so much of free spaces between the molecules, and thereby it changed into gaseous state. So this is called evaporation. Okay. So the next one, condensation. So what is this condensation? So condensation is the process by which a gas is changed into liquid on cooling. So you can see the glass is filled with water vapor or steam. So when you cool the water vapor or steam, it changed into water. The next one, freezing. So what is freezing? The process by which a liquid changed into solid. So water is changed into ice when you cool. Okay. So the process by which liquid changes into ice, or liquid changed into solid on cooling. So this is called freezing. Okay. So now let us see what is freezing, melting, condensation and evaporation. So as I said, melting. So melting always when you heat. So this means heat. Okay. So what is melting? The process by which solids changed into liquids. Solids changed into liquids on heating. Okay. The next one that we saw is evaporation. So evaporation is the process that is also happens due to heating. So here the liquids changed into gas. Liquids changed into gas on heating. Okay. So these two processes are done when you heat. Okay. Now let us see what is condensation. So condensation is the process that occur when you cool. So this means that cool. So here in this process the gas changed into liquid on cooling. So when you cool the water vapor, so the water vapor when it touches the cold surface, so it is changed into liquid. So here the movement of the molecules becomes slow, and thereby it forms a rigid, there is less amount of intermolecular space. The next one that we saw is freezing. So what is freezing? The process by which liquids changed into solids. So the process by which liquids changed into solid on cooling. So, this two process done under cooling method and this do process on heating method. Okay. So, are you clear between the melting, evaporation, freezing and condensation, right? Yes. So, next we will see about expansion. What is expansion? So, expansion is happens when you heat. So, when you heat some substances, so what happens? There is increase in the intermolecular space. So, if there is a matter like this, when you heat it, so the intermolecular spaces will increase. Okay. So, thereby it expands. So, when this changed into this, so the intermolecular spaces increases. Okay. So, thereby it expands, right. So, example is tight lid opens by dipping in hot water, right. So, sometimes when you open a box, so if it is very tight you cannot open it. So, when you dip in the hot water, so the molecules in the lid expands and thereby it is easy for us to open the lid. And one more example is electrical wires hang loose in summer. So, in the summer you can see in between the electric poles you can see the electric wires, right. So, they hang loose in the summer season. So, this is the example of expansion. So, expansion means under heating, in expansion the intermolecular spaces increases. Okay. The next one, contraction. So, what is contraction? So, contraction is under cooling. On cooling, decrease intermolecular space. So, when you heat it, the intermolecular space increases, but when you cool it, the intermolecular space decreases. So, decreases and thereby it contracts. Contracts means surungurathu. Expands means virivadairathu. Contracts means surungurathu. Okay va? So, an example is electric wires do not hang loose between electrical poles in winter. So, in the winter the climate will be cool, right. So, there is decrease in the intermolecular space and thereby it contracts. So, that is why the electrical wires will not hang loose in the winter season. So, contraction means cooling, expansion means heating. Okay. So, next we will see about physical change and chemical change. So, what is this physical change? So, physical change or the changes that is happening by physically. So, mostly it can be reversed. So, it is a reversible change and no new substance is formed and it is a temporary change. So, the example of this is melting of ice. So, when you take ice and you change it into water and again the water can be changed into ice. So, it is a reversible change and when you melt the ice, there is no new substances formed. The ice is changed into water, the water is changed into ice. So, there is no new substances formed and it is a temporary change. Same like melting of wax. So, melting of wax, medugu. So, when the wax when it melts, it becomes liquid and when it cools, it becomes solid. So, this is a reversible change and there is no new substances formed. So, this is also an example of physical change. Next, glowing of bulb. So, when you glow a bulb, again we can switch off, again we can switch on. So, this is a reversible change. This is also an example of physical change. Evaporation of water. So, water can be evaporated into water vapor and water vapor can be again changed into water on condensation. So, this is also a reversible change and there is no new substances formed. It is a temporary change. So, that is why these examples come under physical change. The next one, chemical changes. So, what is this chemical changes? Just opposite to the physical changes are called chemical changes. So, in chemical changes, the process cannot be reversed. We cannot reverse it, right? So, it cannot be reversed. So, it is a irreversible, we cannot reverse. So, it is only one way process. So, once it is changed from that state to another state, we cannot bring it back to the previous stage. Okay. Next, a new substance are formed. So, here in chemical change, new substance is formed. It is a permanent change. So, once you change the state of the matter, it is permanent. You cannot again change the state of the matter. So, these are all the properties of the chemical changes, and let us see what are the examples. So, burning of paper. So, if I burn a paper, the paper is changed into ashes. Again from the ashes, can I change that into paper? No, right? So, it is an irreversible change, and I got the new substance ash. So, that is why burning of paper is a chemical change. And then burning of wood. So, even the wood is changed into ashes, right? So, this is also an example of chemical change. And then cooking of food. So, once you cook the food is cooked, right? So, the rice is changed into boiled rice. So, again the boiled rice cannot be changed into raw rice. So, it is an irreversible change, and the rice, when you boil it, you get the new substance, isn't it? So, that is why this is also a chemical change. And formation of curd. So, milk is changed into curd. So, you get the new substance and it cannot be reversed. So, these are all the examples of chemical change. So, cooking of food, formation of curd, burning of wood and paper are the examples of chemical changes. So, these are the differences between the physical change and chemical change. So, you will get the question in your 5 mark. So, what are the differences between the physical change and chemical change? You can tell physical change, they are reversible. So, they are reversible. So, they are reversible, but chemical change cannot be reversed. It is a one way only. Okay. Then what is that we saw? So, there is no new substances formed. New substance will not be formed in the physical change, but in chemical change new substances formed. And the third property that we saw here in physical change is a temporary change. It is a temporary change. In a chemical change, it is a permanent change. And what are the examples that we saw in physical change? Melting of ice, and then even chopping wood, mixing grey and green marbles, that is also an example for physical change, and shredding of paper. And examples of chemical change are burning wood, rotting of banana. Rotting means padukkurathu, okay. So, once the banana rots, after we cannot get the raw banana, right. Then mixing vinegar and baking soda, that is also an example of chemical change. And then fireworks. So, the fire, you are turning the chemicals into fire, right. So, that is also a chemical changes. So, so in this class you almost learnt about what are the solids, liquids, gases. So, solids have molecules are closely packed and they do not have intermolecular space, and they have a very strong force of attraction. So, they have a definite shape and they have a definite volume. And in liquids you learnt the molecules are loosely packed and there is little intermolecular space, and the force of attraction will be less. And in liquids they do not have a definite shape, but they have a definite volume. So, the example of solids, or you can say ball, wood, paper, book and all. In liquids the examples are milk, water, juice, ink, etc. So, we saw about gases, right. So, in gases the molecules are very loosely packed and they have a very less force of attraction, and thereby they have a large intermolecular space. So, that is why they flow very easily and they occupy all the available spaces. So, gases always takes up all the available spaces. So, examples that we saw is air, oxygen, water vapor or steam. So, these are all the examples of gases, right. So, and also gases, they do not have shape and they do not have size, but liquids and gases flow easily, right. So, these are the properties that we saw about solids, liquids and gases, and we saw solids, liquids, gases in water. So, some solids dissolve in water, some solids do not dissolve in water. So, the solids that dissolve in water are salt and sugar. The solids that do not dissolve in water are wood, chalk and we saw some papers, right. And then liquids. So, liquids that dissolve in water are called miscible liquids. Example, ink, milk, juice. And the liquids that do not dissolve in water are called immiscible liquids. Example, kerosene, oil and petrol, right. And we saw gases also dissolve in water. Oxygen, nitrogen, carbon dioxide dissolve in water, right. So, we all saw all that and we saw about the change of state of matter. So, melting, evaporation, heating, freezing and condensation. And we saw what is the difference between expansion and contraction. Expansion under heating, contraction under cooling. So, when you expand, the intermolecular space increases and when you contract, the intermolecular space decreases, right. So, that we saw, and we saw the important question. So, what is physical change and chemical change, right. So, when there is no new substances formed, it is called physical change, and when there is new substances formed, it is chemical change. And physical change can be reversed, chemical change cannot be reversed. So, physical change is a temporary change, chemical change is a permanent change. What are the examples that we saw in physical change? Yes, burning off, melting off, yes, melting off wax, melting off ice, and in chemical change, burning off paper, cooking of food, right. So, you will get questions related to whatever I have taught you, right. So, now it is a question time. I am going to ask question to Radhika, okay. Now, tell me what is the state of matter that has little intermolecular space? Yes, liquids have a little intermolecular space, right. So, very good. And now, I am going to ask Thirumurugan. So, Thirumurugan, tell me one example of a immiscible liquid. Yes, immiscible means not dissolve. Yes, oil, petrol or kerosene you can say, very good. So, children, go through this lesson again and again and watch this video so that you will come to know a very clear information about this lesson, right. So, in this below description, we have attached the link called Google Drive. Click it so that you will get the details of this lesson, study material, question bank and self assessment. So, copy that in your note and do the self assessment. So, by doing the self assessment, you are going to improve your knowledge, right. So, thank you children, have a good day.